Hello everyone. In this session, we will discuss the next application of the op-amp is the comparator. Here, comparator is a very good application of the op-amp. Here first, what is comparator? Here, the comparator is useful for comparing between inputs. Generally, we have for any op-amp, we have two inputs. It must be useful to comparing these inputs. The comparison by the comparison of the inputs, it will generate output. It will generate the output. Op-amp in open loop condition is used as comparators. We discussed a lot of applications regarding the closed loop configuration. Closed loop configuration means it consisting of the feedback. But here the comparator itself, it is a open loop condition. It is in open loop condition, the op-amp is worked as a comparator. Okay, it is used in analog to digital conversion. So we already discussed the application, last application, the conversion from analog signal to the digital conversion. This comparator circuit is mainly useful to converting the analog signal into the digital signal, right? Here the general comparating circuit is like this. That is simply general op-amp is consisting of the non-inverting and inverting. It will take the two saturation inputs and it will take two biasing inputs. One is V plus for non-inverting input, V minus biasing voltage for the inverting input. By combine together, it will generate the output. Okay. Here V0 is a digital output. Don't forget, it is a digital output simply. This digital output consisting, we already discussed about the digital output. Digital signal is nothing but which consisting of the zeros and ones like that. So for example, 2 is the signal, it is a 3-bit signal. It is represents like this 0 1 0. That is, this is 2 power 0, this is 2 power 1 and this is the 2 power 2. Then combine to get, we will get the signal value is the 2. So 2 is represented in terms of the digits. Okay, so this is mainly useful to converting in the form of digital, that is high and low. High you can take it as the 1, low you can take it as the 0. So this is about the comparator. So in comparator, the output voltage is nothing but the gain into the differential voltage. So gain is here the open loop op-amp, that's why the gain is the open loop gain and the input is the differential input. So but here the output has two limits. If the non-inverting input is more than the inverting input, it will generate the positive saturation voltage, a fixed voltage. That means you can take it, this positive saturation voltage is high value. We can name it as the high value. If the inverting input is more than the non-inverting input, then the output will generate the negative saturation voltage. That means here the negative saturation voltage is nothing but the low value. Maybe 1, maybe the 0, or we can name it 0 or not 1 and 0. It may be the high value and the low value. So this is the output of the comparator. This is the output of the comparator. Here comparators are specially designed ICs. It is not normal things. These are specially designed ICs. What is the meaning of IC? Integrated circuit. What is integrated circuit? Number of components with the resistors and capacitors is fabricated in a single chip is known as the IC. Other than op-amps, it has specially designed ICs other than op-amps. That means these ICs have some important features. Comparator have some important features other than the op-amp. So the reasons are why it require some special features. The first is generally here the op-amp is designed for only the linear applications. Generally op-amps are designed only the purpose of the linear applications. But Comparator is nothing but it is a non-linear application generally. Comparator is non-linear application. Okay, right. Comparators have low propagation delay. It requires very low propagation delay means so it doesn't have any delay. So we are giving the some input and exact that time we should get the output. So we have some propagation delay, we are giving some input, but output initially not getting, it will get after some time. This is called the propagation delay. But comparators have low propagation delay, must and should, and fast rise and fall time. It should be rise time is high as well as fall time is also high. So then it is very speed devices compared with the op-amps. Third, comparators should have two outputs, that is positive saturation and the negative saturation. But in case of op-amps, the output will be varied. This is the special feature of the comparators. Comparators should generate only two outputs. One is saturation, positive saturation, another one is the negative saturation. Okay, so these are the special features of the comparator. So generally we have two types of comparators. In that first comparator is non-inverting comparator. Non-inverting comparator. So here what is the meaning of non-inverting comparator? The input signal must be given to the non-inverting of the op-amp, and the reference signal is given to the inverting terminal. Then it is called as the non-inverting comparator. And the maximum voltage generated by the comparator is plus V saturation, and minimum voltage generated by the op-amp is the minus V saturation, and it will generate the output. Comparator always is a open loop op-amp, that's why we doesn't have any feedback here. So how the output will be generated for B, we will analyze here. Here for example, the input voltage is triangular wave. Triangular wave means it is in the shape of like this. So this is nothing but V input, this is nothing but the input wave. And the reference wave is a straight line. Reference wave is the straight line. Then how the comparator will be acting is like this. Here the input is given to the positive terminal and reference is given to the negative terminal. The output will be generates like this. The output will be like this. The output will, the point where input voltage is higher than the reference voltage, it will generate saturation voltage. That is nothing but it will generate the V saturation voltage. So this is the output, and remaining all are zero, low values. Remaining all are at this region V reference is greater than, that's why it is value is the output is the 0. But at this region the input voltage is higher than the reference voltage. So these are also fixed. But at this point here also the input voltage is higher than the reference voltage. So that's why we are getting like this. That's why we are getting, this is the output. So only one thing, whenever the input voltage is higher than the reference voltage, we are getting the plus V saturation voltage. Remaining all cases is 0. So that's why we are getting the plus V saturation voltage. So this is the output voltage of the non-inverting comparator. A simple thing, input will be positive, it should be high, reference will be negative, it should be low. That time it will generate a digital signal. A digital signal means high value, low value, high value, low value. The next comparator is the inverting comparator. Here inverting comparator is different. Input is given to the inverting terminal, reference is given to the positive terminal. That time the output voltage is like this. Always reference voltage will be high. Wherever the reference voltage will be high, that time the output will be the high value. Wherever the reference voltage is low, the output value is the low. So here at these 2 points only the reference voltage is low. So that's why that's why we will get that's why we will get so we will get where the reference voltage is dominates the input voltage, that time it will generate the high value, and remaining portion it will be wherever at this portion it will be low. Here also at this region the reference voltage is dominates, so that's why we will get the high value, and it will for this region input voltage is dominant, that's why 0. So it will generate the output is like this. Again it is the V saturation voltage, it is the 0. Again it will be the saturation voltage and it will be the 0. So this is the output of the inverting comparator. Inverting comparator output is reverse of the non-inverting comparator, because here input is given to the positive terminal, reference is given to the negative terminal in case of the non-inverting comparator. In case of inverting comparator, input is given to the inverting terminal, reference is given to the positive terminal. So wherever the positive terminal is, that should be high, the remaining terminal that should be low, then we will get that results. Okay, the next is zero crossing detector. Here zero crossing detector name itself, whenever the input is crossing 0 point, it will detects the output. So that is called as simply a zero crossing detector. So here name itself, zero crossing detector is a basic comparator circuit with zero reference voltage. So in the last comparator circuit, we already discussed about the comparator circuit, we are having some reference value, but here reference voltage itself the zero voltage. It is used to detect the sine wave transition from positive to negative. It is generally useful to detect the sine wave from positive to negative. So it will detect how the sine wave is varied from positive magnitude to negative magnitude. It will also detects when the input crosses from zero voltage condition. It will detect when the input is crosses from the zero voltage condition. It will give positive to negative transition. Okay, this is about the zero crossing detector. Name itself, it will detect the way it crosses the zero, when the input crosses the zero. Simply it is applicable as a sine wave to square wave converter. It is also useful to convert from sine wave to square wave. It is very much useful. Again here zero crossing detectors are generally two types. One is inverting zero crossing detector, another one is non-inverting zero crossing detector. So now we will discuss about these types. Here first is inverting zero crossing detector. So inverting zero crossing detector. So name itself, inverting zero crossing detector means we are giving the input voltage to the inverting terminal, and this is nothing but you can take it as V1, no problem. And the reference voltage, this is the reference voltage that should be given to the ground. Okay, and we should have some biasing. One is positive saturation biasing, negative saturation voltage. These are the maximum voltages, and it will generate the output here. Here zero crossing detector itself, the V reference value is the 0. We know that. Okay. Here what happen means, when the input is given to the inverting terminal and reference voltage is given to positive terminal, that time it will generate some output. The output should be the negative value. The output is like this. The output should be the negative value. It shows some negative value. And for the positive half cycle, if the negative half cycle is applied to the inverting terminal, it compare with the reference voltage, then it will generate the positive voltage. Same for positive terminal, it will generate the magnitude of negative saturation. This magnitude is negative saturation, and after that it will generate the positive saturation like that. What happen means simply whenever V input is greater than 0, then output voltage it generates minus V saturation. And the way whenever V input is less than 0, the output voltage must be positive saturation voltage. Positive saturation voltage. Because here the inverting is there. Inverting means itself the output will be varied like that. So here we can draw the transfer characteristics. We can name it, these are the transfer characteristics. These transfer characteristics are like this. So wherever V input is positive side, the voltage will be the negative voltage. So that's why the transfer characteristics are like this. So whenever the V input is positive, the transfer characteristics will be generated as the negative simply. And whenever V input is the negative side, the transfer characteristics are the positive. The transfer characteristics are the positive. Okay. So this is about the inverting zero crossing detector. The next is the non-inverting zero crossing detector. Here name itself non-inverting means the input value is given to the positive terminal and the reference voltage is 0. Now here directly we are giving the non-inverting, that means positive side. So whenever the positive side, so whenever here V input is greater than 0, then automatically whenever input side is sinusoidal wave, it is greater than 0, then output is, we are giving the signal to the positive, that's why the output directly generated, that is the positive saturation voltage. So directly we will get the saturation voltage value is like this. This is the positive saturation voltage. Next, when V input is less than 0, then the output must be the negative saturation voltage. So negative saturation voltage means the output is like this. The output is like this. This is the positive saturation voltage and this is the negative saturation voltage. Okay. So when the input is given to the positive terminal, then automatically plus V saturation, otherwise minus V saturation. So these are the transfer characteristics. So transfer characteristics are, when V input is positive, then automatically always the output should be the positive, and the V input is negative, then the output is should be the negative. Output is should be the negative. So these are the difference between the transfer characteristics. These are the positive side input and these are the negative side input. This is the positive side output and this is the negative side output. Okay, this is about the simply zero crossing detector. Okay, so I hope all of you understand this zero crossing detector as well as comparator circuit. Thank you.